Now we are entering on that is known as the thermochemistry. As we were talking even on the first time when we explained and talked about the course outline and the units that this course will have, thermochemistry is the first unit that we are working with. In a big shell, what this unit is talking about is the energy transfer. So what is happening when a chemical reaction is uh, dealing is ongoing? What is happening with the energy? Why some reactions have the energy given to the environment and some reactions have the energy that is absorbing from the government, and and what is happening, why some reactions are releasing more energy and why some are absorbing more or less energy. All those things and all the way that those big questions will be the one that we will be dealing with in this unit. So it is looking at the chemical reaction from the energy perspective of it. Why, how much, why this way, and why not that way. Okay, so the very first thing that we will see in the in the this part of the lesson is kind of some general terminology. So we said that when we are dealing with the chemical reaction and looking at what is happening with the surrounding, that means that we have two parts here. One part that is the reaction, and the other part that is the surrounding. Um, so an interaction is happening between the reaction and the surrounding. Now, even from previous science classes, we know that there are two types of energy: the kinetic energy and potential energy. So now kinetic energy uh, is the energy that is dealing with particles when they are moving. And potential energy, the word is saying it, is the ability that something, in this case of a chemical reaction, has to uh, do work, because energy and work are interchangeable to each other. So when we say energy, then we means work. When we say work, we means energy. So kinetic and potential. However, the sum of those two potential energy is the internal energy of the system, or the energy of the system. The sum of both is the internal energy of the system, or simply the energy of the system. Okay. Now, the internal energy of the system is known as the enthalpy of the system, and we cannot possibly measure it. Okay, we cannot measure what is the total internal energy of the system. However, so this one here is, in other words, is known as the enthalpy. But what we are able to measure is the change that this internal energy is undergoing. So we cannot measure the absolute value of the internal energy or the energy of the system, but we are able to measure what is happening when the system is moving from this state to that state, and then measure and compare the two internal energy, and then identify the change that the enthalpy is going through, or the change that the sum of kinetic and potential energy is going through. Since we are not able to measure the absolute value of the enthalpy of the system, or in other words, since we are not able to measure the internal energy of a system, the sum of kinetic and potential energy of the system, we look at the change. And the changes that the enthalpy can experience are two: heat, change of enthalpy are two, is heat, and the second one is work. So if you see the energy that is between the two objects, then there is a temperature difference between the two. Then the exchange of the energy between the two objects will be happening. One will absorb, the other one will release, until that is known as the thermal equilibrium is reached. So this is heat. And work, what it is work, even from the previous classes on Science 10, you know that work is of a force times distance done along force that is applied in the object times the distance. In chemistry, a common type of work is when we have, let's say, expansion or compression of a gas. This was a subject of chemistry 20. We will not go into that now, because now you are on chemistry, in chemistry 30. The most that we will see on this unit is the heat transfer. So when it is absorbed, when it is released, why is it absorbed, why is it released, how is it cooled, and so on and so forth. Okay, now it is important. We have two parts here. We have the chemical reaction and we have the surrounding. Okay, so a chemical reaction is happening, and then you are saying that, well, I see that the air is warming up as a result of this chemical reaction. So what do we see? What do we see from the perspective of what we feel is that what is happening in the surrounding. However, this what we see happening in the surrounding is as a result of the changes that is happening in the chemical reaction. In chemistry, we agree to consider the change of the energy from the perspective of the chemical reaction. Okay, so what is happening in the chemical reaction, or what is happening in the system? Okay, so the reaction is known in the other words as the system. And now, you know, even from the previous one, that there are three types of systems. There are three. It's the one that is the isolated system, where the energy and the mass is not changing. Okay, cannot be transferred to the surrounding. Okay, so the isolated system is very hard to create, even in our everyday. A closed system is the second system. A closed system is where the energy can be transferred, so the exchange of the energy is happening, but mass is not changing. And the third one is the open system. This is the most common that we see even in our everyday, where the matter and the energy can be transferred from the system, from the chemical reaction to the surrounding. Okay, so isolated mass and energy cannot be transferred. Closed system mass will not, but the energy uh, will transfer, and open system, both of them will transfer. Okay, so when we see those three types of system, the isolated one, matter and energy will not transfer, will stay in the system, will not move to the surrounding. The closed system, which is the system that we mostly deal, especially in thermochemistry, where the energy will transfer from the system, from the chemical reaction to the surrounding, but matter will not, will stay on the same place. And then the third one, which is in reality is the one that we see in every day, is the oven system, where the matter and the energy moves from one place to the other, in this case from the chemical reaction to the. Now, in terms of the energy sources that we see and we have in our uh, Earth, the main source of energy is the sun. You will see this probably even on the diploma, but definitely in the unit test, you will see this question. What is the main source of the energy? And then do not forget that the main source of energy, the main source that we are dealing with into our Earth is the sun. However, in something that, and I prefer to not make you remember a lot of things. However, especially in chemistry, there are some things that are very, very helpful for you to remember and to know. The two reactions that are using creating energy or creating some types of energy and using the energy are photosynthesis and cellular respiration. Now, you have to remember those two balanced reactions and know what is and how are we using them, what is the purpose, what are they doing. So the first reaction is photosynthesis, and photosynthesis is a reaction in which you are producing glucose, which is a source of energy, and oxygen. So the balance reaction for it is 6 carbon dioxide plus 6 water will give you glucose and oxygen, 6 oxygen. Remember this reaction as a way to produce energy, because glucose is a form of energy. And the other reaction that, again, you have to kind of memorize it, but it is easy to, is cellular respiration, which is the opposite. So you are using the energy that is formed here, burning it out with oxygen to produce carbon dioxide and water. So it's the opposite reaction of photosynthesis. So glucose and oxygen are producing carbon dioxide and water. I will suggest to you to remember and memorize those two reactions, as the first one being producing energy, and the second one is using that energy.